This will be our first video on differential calculus. Now, before we start, calculus can be divided into differential calculus and integral calculus. Differential calculus focuses on the gradients of tangents and curves, and integral calculus focuses on areas underneath curves. For grade 12 mathematics, we only focus on differential calculus. Our first lesson would be to find the average gradient between 2 points. In this diagram, we have the function of x squared minus 4x plus 3 drawn. And two coordinates on that function is given, 0 and 3, and 6 and 15. And we want to find the average gradient between those 2 points. In previous grades, we learned that gradient is part of the straight line. So the gradient represents the angle at which we draw the straight line between 2 points. And we are going to use the normal gradient formula to find the average gradient between these 2 points. So remember, the gradient is the difference of y's over the difference of x's, and then I used the coordinate on the right as x2 and y2, and the one on the left as x1 and y1. I have substituted those values in and simplified. So the average gradient between these 2 points is 2. In the second example, we want to find the gradient between x equal to 1 and x equal to 3 for the function fx equals to x squared plus 4. Now, we already have 2 values for x, and we still need 2 values for y. We do not need to draw the function. We can simply use our normal method of finding gradients. So, where x is equal to -1, I substitute -1 into the function, and I find that the y value is 5. And where x is equal to 3, I substitute 3 into the same function, and I find that the y value where x is 3 is 13. So I have 2 coordinates, -1 and 5, and 3 and 13. So the gradient is equal to the difference in y's over the difference in x's. We can also write the gradient in a slightly different way. So the gradient of the function where x was 3 minus where x was -1 in the function over 3 minus -1. So notice that y2 is represented in the function where x is 3 and y1 is the function where x is -1. And we need to get used to this form of writing for our next lesson. So when x was 3, the function was 13. Where x was -1, the y value is 5 over 3 plus 1. So that is 8 over 4, and therefore the gradient between those 2 points are 2. So the gradient is equal to 2 between x equal to -1 and x equal to 3. Our final example for today, we are going to find the average gradient for gx equals to x cubed over the interval of -1 and 3. This interval is not a coordinate. This is between x equal to -1 up until x equal to 3. So the gradient is the difference in y's over the difference in x's. So our y values we would find for substituting 3 into the function and -1 into that same function over the difference in x's. Notice I'm substituting 3 in first, so the first x value is 3. And then I'm subtracting the value of gx when x is equal to -1. So I have -1 second in our x values. So now I substitute both values of x into gx. So 3 to the power of 3 minus -1 to the power of 3. That is 27 plus 1 over 4. That's 28 over 4, so the gradient is 7. Alternatively, you could have substituted the values first and then put those values into the gradient formula. So both methods will give you the same answer.